Mohapriya. We're going to see about virtual machines. A virtual machine is a software-based emulsion of a physical computer. VMs allow multiple operating systems to run on a single hardware system. They provide isolation, flexibility, and efficient resource utilization, used widely in cloud computing, testing, and development. The importance of virtual machine is enables efficient hardware utilization, supports isolation between different environments, allows running multiple OS instantaneously simultaneously. The history of virtual machines starts from 1960. IBM introduced virtualization on mainframe. In 1970s, the VM by T70 by IBM allowed multiple OS instantaneous. In 1980s to 1990s, declined due to improved OS multitasking. In 2000s to present, the cloud computing on modern hypervisor boosts VM usage. The basic concept of virtualization is virtualization allows multiple virtual environments on a single physical system. It abstracts hardware, resources, and improves efficiency. The key benefits: scalability, cost effectiveness, and isolation. The types of virtual machine. System virtual machine simulates an entire physical computer, example VMware, VirtualBox, Microsoft Hyper-V. The process virtual machine runs on a single application or process, example Java virtual machine, NetCLR. The key components of virtual machines are host machine, the physical system where the VM runs, guest machine, the virtual system inside the virtual machine, hypervisor, software that manages VMs, the virtualization layer, interface between hardware and virtual machine. The virtual machine architecture components are virtual CPU, memory, storage, and network interface. The host OS runs a physical hardware and manages hypervisor. The hypervisor enables VM execution and resource allocation. The guest OS operates within the virtualized environment. What is hypervisor? Software that creates and manages virtual machine. Two types. Type 1 hypervisor, bare metal, run directly on hardware. VMware ESXi Hyper-V. And type 2 hypervisor is most hosted, runs on a host OS, Oracle VirtualBox, VMware workstations. How virtualization works. Hypervisor loads and manages multiple virtualization machines. Resource CPU, RAM, storage are allocated to each virtual machine. Each virtual machine runs into own OS independently. Isolation ensures security and stability. A working of a virtual machine. Hypervisor creates a virtual environment that mimics hardware. The guest OS is installed on the VM and runs application. Hypervisor manages resource distribution among VMs. VMs operates independently on the host OS. The resource allocation in VMs. The CPU cores are allocated based on the workload requirements. RAM allocation ensures optimal performance for each VM. A virtual storage is mapped to physical drivers on cloud storage. The networking is managed through virtual network interface. The advantage of virtual machines: efficiency, hardware utilization, isolation between application and OS, isolation enhanced security and stability, cross-platform compatibility, allows multiple OS instantaneous on single system, easy backup and snapshots, software legacy software, supports simplifies backup recovery in system migration. The disadvantage of virtual machines: perform overhead due to virtualization layer, requires high system resource, example RAM, CPU, storage, complex setup and maintenance, potential licensing and compatibility challenges, Security vulnerabilities in hypervisor. Security vulnerabilities is not properly managed. Application of virtual machine. When VMS enable cloud service like AWS, Azure, and Google Cloud, business uses VMS to scale application on demand. Cloud-based VMS provide cost-effective IT infrastructure. Disaster recovery and failover machines rely on virtual machines. Cloud computing like AWS, software development and testing runs different OS versions. Server utilization optimize hardware usage. Security sandboxing malicious programs. Gaming and legacy software run older OS version. VMS in software development and testing. Developer use VMS to test software across different OS. Isolated environment prevents system conflicts. Continuous integration pipeline rely on VMS. Cross-platform application development is simplified. VMS in cybersecurity. Sandboxing techniques uses VMS for malware analysis. VMS provide isolated test environment for security research. The cybersecurity professional use VMS for penetrating testing, and forensic investigation leverages VMS snapshots. Role of virtual machine in cloud computing. Cloud providers uses VMS to host services, enable on-demand scaling. Example: AWS EC2, Google Cloud Computing Engine, Microsoft Azure VMS. Security aspect of virtual machines. Isolation prevents malware spread. VM snapshots provide data recovery. Hypervisor security is critical. Regular update reduce vulnerabilities. Performance optimization in virtual machines is use lightweight hypervisor, allocated proper resource, and CPU RAM storages. Enable hardware acceleration VTX, AMDB. Use storage optimization SSD. Write. Virtual machine uses container. VMS provide complete OS emulsion while containers share the host OS. The container like Docker, Kubernetes offer lightweight visualization. VMS ensures strong isolation but are resource intensive. Containers enable faster development and scalability. Light migration and load balancing in virtual machine. Live migration allows virtual machines to move between physical hosts without downtime, used in data centers to balance server loads dynamically. Ensure high availability and resource optimization, critical for cloud service providers and enterprise solutions. Challenges in virtualization: performance overhead lower than physical machines, resource allocation issues, poorly managed VMS cost, inefficiency. Security risks: hypervisor can be targeted by hacker. Complex management requires advanced skill and tools. Future of virtualization machines. Faster hypervisor reduce overhead. AI and machine learning for resource optimization. Hybrid virtualization models, VMS plus containers. Integration with edge computing. Virtual machine in real world. Google Cloud uses VMS for hosting web service. Netflix runs its services using VMS and containers. Facebook uses VMS for testing and scalability. And the conclusion is, the key takeaways are: virtual machines enable flexible multi-OS environment. The hypervisor manages VM execution efficiently. The VMS plays a major role in cloud computing and security challenges exist, but advancement will improve VM performance. As a conclusion, the virtual machines are essential for modern computing. They enable efficient resource utilization and scalability. Despite challenges, VMS remain crucial for cloud security and development. Future advancement will further optimize virtualization technologies. And